Hi everyone. This video is to give you a quick review of how to do 45, 45, 90 triangles. This is the way I usually think about it. It's a little bit different from the other video. So if you didn't like the other video, this might give you a different way to think about it, and maybe this will make a little more sense to you. Just a quick geometry review. We get the 45, 45, 90 triangle ratios from a square. If I were to draw the diagonal of the square, we know that all four sides of the square are the same length, and all four of the angles of the square are right angles. If we let each of the sides of the square be a length of 1, then notice that the diagonal divides the square into two right triangles, which means we can use the Pythagorean theorem. So 1 squared plus 1 squared equals c squared. And then 2 equals c squared. So our hypotenuse is the square root of 2. So, for any 45, 45, 90 triangle, the two legs will be the same length, and the hypotenuse will be square root of 2 times each of the legs. Remember, I can also show a 45, 45, 90 triangle by marking the two legs the same length and the right angle. I could also label the two angles as having the same angle measure and then having the right angle. So a couple quick examples. If you can't always remember it off the top of your head or you're more visual, it might help to draw the triangle first. So knowing the ratio, filling out the triangle is really simple. In the first two examples, I'm given a leg, so let's start with the freebie, the fact that both of the legs are going to be the same. So this one here is 15, and this one here is 4 square root of 2. And now since I have the legs to get the hypotenuse, I can look at my original figure, and I see I just have to multiply by square root of 2. So the hypotenuse here is 15 square root of 2. The hypotenuse will be 4 square root of 2 times square root of 2, or 4 square root of 4, or 4 times 2, or just simply 8. If you do enough of these, you'll start to notice a pattern that when you have the square root of 2 in either one of the legs, when you multiply by a square root of 2, it's just going to double that coefficient that's in front of the square root of 2. So if both of the legs were 6 square root of 2 in a 45, 45, 90 triangle, then the hypotenuse would be 12. If I'm given the hypotenuse, I have to go the other way. So for both number 3 and number 4, I'm going to divide by the square root of 2. Now for 3, this one's really simple because I notice I have the square root of 2 in the hypotenuse, so I can see that both of these are just going to both be 10, and I have my ratio. 4 is a little trickier for two reasons. One, the hypotenuse is an odd number, and 2, I'm going to have to divide it by the square root of 2. So for the purpose of class, 5 divided by square root of 2 is a completely acceptable answer. You will never see that choice on a multiple choice test though. So we need to still get in the practice of rationalizing the denominator. which means we multiply both the numerator and the denominator by the square root of 2, and we end up with 5 square root of 2 divided by square root of 2 times square root of 2 would be square root of 4, which is just 2. So I can put it as 5 square root of 2 over 2. I might want to write it as 5 halves square root of 2. Even 2.5 square root of 2 gets the point across, although that would probably be a little more unconventional way of writing it. But notice that same kind of pattern and that same relationship between the legs and the hypotenuse of the 45, 45, 90 triangle. When I multiplied by the square root of 2, that just happened to be double the coefficient that was in both of the legs. And when I divide by the square root of 2, notice that the coefficient in front of the square root of 2 happens to be half the hypotenuse. So again, don't use that rule if you're confused about it, but if you can notice the relationship and you do enough of them, you'll start to see that and you'll just naturally start to do that in your head, hopefully.